Hello viewers, I am Dr. Neha from ABES Engineering College, Ghaziabad, and today we'll be discussing about organometallic compounds, specifically about Grignard reagent and lithium aluminum hydride. First, we must understand what organometallic compounds are. The compounds in which carbon atom is directly linked to metal atom is called as organometallic compound. Grignard reagent, you can see carbon is directly linked to magnesium, thus representing organometallic compounds entirely. This is ferrocene, where we can see two aromatic rings in which iron is being connected to them. And here platinum is connected to the carbon, here in ethene and zc salt. So ferrocene and zc salts I have mentioned here because sometimes they ask the structures of these in exams. Now we'll understand how organometallic compounds of any kind are synthesized in industry. The first method is by direct addition of metal. Here, metals which can be alkali, alkaline, or transition are treated with alkyl halides in presence of suitable organic solvents as diethyl ether. Then organometallic compounds are formed. Here you can see the Grignard reagent's preparation. Alkyl halide is reacted with magnesium in presence of diethyl ether to give RMGX, that is Grignard reagent. Here, the presence of diethyl ether is important because it's an aprotic solvent and it ensures that RX reacts with Mg. In case we don't take diethyl ether or there is a protic solvent over here, instead of Mg, Rx will react with H and formation of alkene or alkene will be occurring. Thus, this is a precaution we have to take, the maintenance of diethyl ether in the medium if we are preparing the organometallic compound. Second step of synthesis is by using alkylating reagents. Alkyl magnesium and alkyl lithium reagents are used with halides of metals or non-metals in presence of diethyl ether to form organometallic compounds. You can see over here, lead chloride is being used with magnesium chloride, that is Grignard reagent, for the formation of organometallic compounds. By metal exchange reactions, organometallic compounds can be prepared by replacing the metal atom in organometallic compounds, a different metal to obtain wide range of organometallic compounds. So you can see the exchange reactions of metal. Here zinc is replaced by calcium and yes, mercury is replaced by sodium. By alkyl halogen exchange reaction is the fourth method. Here you can see alkyl halogens are reacted and here the halogens are being changed instead of metals. Now we'll think about Grignard reagents, their preparation and properties along with applications. Grignard reagents are prepared by direct reaction of alkyl halides with magnesium metal in presence of anhydrous ether. As we told, the ether is an aprotic solvent in absence of which alkanes will be formed instead of Grignard reagents. So we have to ensure that while we are doing this reaction, it should be occurring in the presence of anhydrous ether. Here, R is organic halide, which can be primary, secondary, tertiary in nature. It can also be an allyl or aryl alkylaldehyde. That means the aromatic compound or ring can also be here. The ease of formation of Grignard reagent among halogen follows the given order. So iodine forms the most stable reaction, then bromine, then chloride. Now the properties and applications of Grignard reagent. First, formation of hydrocarbons. So if we do this reaction in presence of a protic solvent, then we form a hydrocarbon. Second, formation of alkenes. The Grignard reagent brings forth the formation of alkenes when they're treated with allyl halides. So you can see over here, it's allyl halide reacting with Grignard reagent, resulting into the alkenes. Synthesis of higher alkynes. Same is the reaction. That means possession of at least one or more active hydrogen. Reaction with Grignard reagent should take place to form alkene allyl magnesium halide, which further reacts with alkyl halides to form higher alkynes. And the most important application, which is used in industry as well, is Grignard reagent synthesis of alcohol. So here, primary, secondary, tertiary alcohols are formed readily and easily by Grignard reagent. Here, that is the general mechanism. This is the carbonyl compound. The major substrate is carbonyl compound. When reacts with Grignard reagent, it forms a transition compound, which further converts into the alcohol in presence of aliphatic hydrolysis. So here we will understand how the reaction takes place. So for the formation of primary alcohol, we use formaldehyde. Here, the bonds, because of different electronegativity, will be breaking in this way. Oxygen will get negative charge and carbon will be positive. R, Mg, magnesium being a positive, being a metal, will have the positive charge and R will be negative. So there, this alkyl group will attack carbon and this magnesium will be attacked with the oxygen and this intermediate will be formed. Here you can see an R is added into the formaldehyde. And here O and Mg are attached Here, magnesium again being a metal, it will hold a positive charge and oxygen a negative charge. Further reaction will be in presence of acidic hydrolysis, which will replace this hydrogen with hydrogen, replaces magnesium with hydrogen, forming alcohol. And here we'll get the magnesium along with halide and OH as a byproduct. We'll get the primary alcohol. Similarly, for secondary alcohol, instead of formaldehyde, we'll take acetaldehyde. Same reaction will take place. R will be added over here, so it will result the secondary structure. Similar acidic hydrolysis will result into secondary alcohol with this byproduct. And similarly, for tertiary alcohol, we'll take the acetone and further tertiary alcohol will be formed. Now, the next organometallic compound is lithium aluminum hydride, which is popularly known as LiAlH4. Is a reducing agent that is commonly used in organic synthesis. It's a nucleophilic reduction agent that is best suitable for reducing multiple polar bonds such as C-double bond. The lithium aluminum reagent is capable of converting aldehydes to primary alcohols, ketones to secondary alcohols, carboxylic acid and esters to primary alcohols, amides and nitrides to amines, epoxides to alcohols, and lactones to diols. Here, this is the structure of lithium aluminum hydride. Now, the synthesis. Synthesis include two types. First is synthesis of lithium aluminum hydride with aluminum chloride. So, lithium hydride reacts with the aluminum hydride in an ether solution, which gives a additional product, lithium aluminum hydride, and LiCl as a byproduct. Industrially, this method is not taking place. It's a different method where preparation of sodium aluminum hydride is done in the first way, and then LiAlH4 is synthesized via salt metathesis over here. You can see sodium, aluminum, and hydrogen are taken separately. They fuse together to form sodium aluminum hydride. This is further reacted with LiCl, which gives lithium aluminum hydride and NaCl as a byproduct. Properties of lithium aluminum hydride. It is a white solid commercial sample, gray due to impurities. It produces hydrogen gas when it reacts violently with water. As a result, it should not be exposed to moisture and the reaction should take place in inert and dry surroundings. This reaction can be used to generate hydrogen in laboratory. So as we know, recently hydrogen production as a fuel is a hot cake in industry. So thus this reaction is also used for the production of hydrogen. Lithium aluminum hydride is moisturized, leading to high production of pure hydrogen and aluminum hydroxide along with lithium hydroxide. The reduction reaction with LiAlH4 as reducing agent must be carried out in anhydrous non-protic solvent, same as the Grignard reagent. Here, aprotic solvent should be taken. Now, the application first, the reduction of carbonyl compounds that we have started in the introduction. We can see the reaction over here. So, this is acetaldehyde. It is being converted into the primary alcohol. This is tertiary aldehyde, tertiary alcohol. Similarly, carboxylic acid. It is different carboxylic acids and acid chlorides are there, which are getting converted to the primary alcohols. And the most important application is conversion of amides to amines. So you can see over here is primary, secondary, and tertiary amide, which is being reduced to the primary and secondary and tertiary amine. Reaction is given. It occurs in the presence of LiAlH4, which reduces it further, followed by the acidic hydrolysis. Similarly, in the case of Grignard reagent, thus we have not discussed the mechanism over here. These are the references from where we have collected this data, and it can help you in the detailed study of the topic. Thank you so much.